Hello, welcome to the San Francisco Bay Area chapter of the ACM for tonight's event. We have guest speakers that will speak on the topic of multimodal DL to detect depression and visual intro to algorithmic thinking. Thank you for attending, and we really look forward to the talk from these students. Before we start, a little bit about our chapter. We are the San Francisco Bay Area ACM, and we're founded in 1957. So we're one of the oldest professional computer organizations. And our purpose for being is to promote knowledge of modern computing, also to create community, support networks, and to help out for people that are looking to be hired or for people looking to hire. In order for us to support our efforts, we have a membership fee of $20 a year. Yeah, that's right, only $20 a year. So, we please encourage any computing professional to sign up and support us. So we really appreciate that. Typically, every month we have 2 meetings, but that can vary. We have, in general, the categories are general computing and data science. So the focus would be on, for data science is on big data, machine learning, and so forth. In addition, there may be networking and job announcements made, or also we may be featuring joint meeting schedules with other professional organizations such as the IEEE or ValleyML.ai.
May I comment briefly? On the previous slide, when we do job announcements, one thing people could do in the Zoom mode is maybe in the chat window, type their job description, company name, if there's a link, if they want to offer that. But that'd be an easy way just to share a job opening.
Oh, great. Okay, thank you, Greg. Wanted to point out a few of the upcoming ACM webinar events. The next is on Wednesday, July 26th. And the topic is measuring and improving engagement in online learning by Manasi Ganti, who is a rising senior at Monte Vista High School in Cupertino.
2 other talks coming up that are on the data science side. 4th Monday in August, secure and interpretable AI, scalable, interactive, and practical tools. So this is an ACM distinguished speaker. And then in September, we have another ACM distinguished speaker in battling for a deep fake dystopia. She'll be talking about how people can create different deep fakes, some of the problems with that, and trying to address issues around that. Also detecting some of the deep fakes that sometimes can cause problems. A deep fake is where you could generate something that looks like a celebrity saying something that they wouldn't normally say, as an example. So I'll finish sharing and turn it back over to Mike.
So in tonight's talk, for those who have questions, please use either the Q&A in the Zoom, or you can raise your hand or chat if there are issues with the Q&A. And the moderator will try to get to the questions either real time or possibly hold it off towards the end of the talk. I'd like to introduce SR, who is going to be the host of tonight's event. So SR, take it away.
Hi, good evening. This is SR Venkatramanan, and it gives me pleasure to introduce tonight's speakers, Claire and William, and the third one, Raymond, is missing. Claire won a 2nd place student award in Synopsys Science and Engineering Fair. She also won 1st place in anti-COVID-19 Young Scholars campaign by creating a Corona Buster application with her team. In addition, Claire has co-authored a book with Raymond, Algorithmic Thinking for Adventurous Minds, and that can be purchased on Amazon or other booksellers. Going through Claire's work was really amazing before we went through this process of elimination and everything. So I'm really amazed to see the amount of work and rigor she has kept in doing this work. And congratulations to her. She, besides doing these things, she loves to play tennis and draw. The drawings won first place at Council PTA and were published in the newspaper also. The next one speaker will be the William. He's currently a second-year student at Emory University, studying biology on a pre-med track. He has coded chemistry simulations, including the titration lab. Other projects he has done include image recognition, location finders, algorithm solvers, and fun games as well. He's the co-author of the algorithmic thinking for adventurous minds that I just mentioned with Claire and Raymond. They are going to start doing this presentation on their work, both their work. And as a courtesy, please hold your questions towards the end so their thought is not interrupted. Thank you.
So I guess welcome everyone to attend today's seminar. First of all, we'd like to thank the Association for Computing Machinery, San Francisco Bay Area Professional Chapter, Ms. Liana Ye, Mr. Mike Fong, Mr. SR, and Mr. Greg for giving us this opportunity to share our learning journey on our research project, which is AI depression detection, as well as our visual approach to introduce algorithmic thinking, which is documented in our book. Thank you for helping us on the event planning and confirming the detail.
We'll have three presenters, Claire from the Harker School, William from Emory University, which is me, and Raymond from the Harker School as well. He is currently in data science project meeting, so he prepared a short video ahead of time. We'll play the video in the middle of our presentation. Many of us are facing challenges that can be stressful, overwhelming, and cause strong emotions. Public health actions such as social distancing are necessary due to reduce the spread of COVID-19, but they can make us feel isolated and lonely and increase stress and anxiety. Loneliness is at the root of many mental health issues. During COVID-19, the depression rate has increased by 40.9%.
So a CDC online survey indicates that young people between the ages of 18 and 24 are more likely to suffer mental health problems during the pandemic than any other age groups. So according to the Forbes News on April 13th, 2021, which is only 3 months ago, for young people who are navigating choices about higher education, their careers, building relationships, the uncertainty of the pandemic can add pressure to already stressful decisions. For example, I know a few high school students who prepared for the SAT exam, but it got canceled last minute. And also about college students, they have to debate whether to stay in their college dorm rooms or live at home and study remotely. They may feel like their options are restricted or like their lives are on an endless pause during a critical developmental stage. And teenage and young adults' brains are wired for new experiences, and that developmental need is not being met. And with the long stretches of time spent away from friends and family, young adults tend to use social media as an outlet and form of connectivity with the world around them. Connections on social media can sometimes create mutual support and help build a support system. However, dialogues on social media can quickly turn toxic and trigger negative emotions. Another cohort population we should pay attention to is the lower income families. They're 59% higher diagnosed with depression, but 40% less visits to clinics. And here we would like to give a couple of examples. So K-pop is a very popular music among teenagers and young adults. And if you know BTS, which is the biggest K-pop boy band in the world and has around 40 million fans, its member Suga expressed his depression in the August D album. Or if you're a tennis fan, you must know Naomi Osaka. She explained in June this year that she woke up and felt really depressed, but didn't know why. She is also introverted and often wears headphones as that helps her dull her social anxiety. So her depression started since the US Open in 2018. And we all experience some depressive moments in our lives. And the delayed depression detection and intervention process leads to the drop of recovery rates. Approximately 60% at 2 years, 40% at 4 years, and 30% at 6 years. So we decided to do something about it. We've reviewed current ways of depression detection in psychiatric clinical settings. as well as existing AI approaches. Then we developed our own interdisciplinary multimodal approach for early depression detection. And now reviewing the psychiatric clinical approach. So American Psychiatric Association, which is also known as APA, Diagnostic and Statistical Manual, defines the 9 depressive symptoms groups as shown on this slide. So let's just walk through these symptoms one by one with example and have a moment to retrospect ourselves and hope none of us matches these symptoms. So first one is loss of interest. An example tweet that we found on Twitter is that party is not even fun for me. Nothing is fun. And then there's sadness, which might be gloomy, heartbroken. And then third one is sleep disorder, which may be the night is so long, we're in the darkness forever. And the fourth one is tired, which may be so drained, I'm done. And the fifth symptom might be appetite disorder, which can be go away, food, it makes me fat. And then there's guilt, which is I'm nobody, I'm hopeless. And then concentration issue may be represented by focusing on the task at hand is so difficult for me. And then there's movement, which might be don't want to do anything. And then last one, which is probably the darkest one, is suicidal ideation, which can be represented by I just might kill myself. And then the National Institute of Mental Health presents a list of questions that an individual should consider answering if he or she wants to check for depression. And all these questions are aimed to surface the 9 symptoms that we just saw. And the patient health questionnaire is a clinical tool used to assist the clinician in the diagnosis of depression, to quantify depression symptoms and to monitor the severity. And the questionnaire was developed by Dr. R.L. Spitzer, J.V.W. Williams, and colleagues with an educational grant from Pfizer. And yeah, it's the same company that developed the Pfizer COVID-19 vaccine. And surveyees were also asked to evaluate their depression indicative signals in the past 2 weeks. And please note here, the evaluation is based on a prolonged period of time instead of a snapshot of time. So instead of just like evaluating one day, which may be like if that person had a test, they would be super stressed, and that may affect their outcome of the clinical approach that they took. Or instead, they just like have a 2-week time so that it's like 2 weeks and not just one day, and that may have a more accurate effect. And so this increases the accuracy of the detection. And many of the existing AI approaches are based on a snapshot of time. So you'll see that in our later slides, that in our approach, we batch Twitter data in a 2-week period of time to detect more persistent depression symptoms. And for example, here is basically the patient health questionnaire 9, which is PHQ 9. And then the instructions kind of is like, over the last 2 weeks, how often have you been bothered by the following problems? And here are some prompts that you get. And then you can answer the question, which is 0 is not at all, 1 is several days, 2 is more than half the days, and 3 is nearly every day. So here, if you have little interest or pleasure in doing things, it may be several days, for example. And then feeling down, depressed, or hopeless, it can be not at all. And then trouble falling asleep, staying asleep, or sleeping too much, that can be several days maybe. And then number 4 is feeling tired or having little energy. That may be several days too. And then poor appetite or overeating, that may be not at all, for example, again. And then feeling bad about yourself, or that you're a failure or have let yourself or your family down, that may be not at all. And then there's trouble concentrating on things such as reading the newspaper or watching television. That can be not at all again. And then the last 2 questions, which is moving or speaking so slowly that other people could have noticed, or the opposite, being so fidgety or restless that you have been moving around a lot more than usual. That may be several days, for example. And then last one is thoughts that you would be better off dead or hurting yourself in some way. And this may be the most extreme one. So let's just go with not at all. And then it adds up all the points for you. So in this case, there's 4 points. And then down here, when you scroll down again, you see this table and it shows you the points that you get. So if you got 0 to 4 points, which we got 4 points right here, it's going to show that we have non-minimal and the proposed treatment action is none. And as you can see, if you get 5 to 9 points, which is mild, you get a certain proposed treatment action. And then the same goes with 10 to 14 points, 15 to 19 points, and the last one, which is 20 to 27 points. So going back to the slide, I guess, here's like basically the table that we just saw. But however, there are also issues with this questionnaire-based approach. So first one is that cognitive bias leads to untruthful responses in a clinical environment, which means that patients can like fake the answers to get their desired results. For example, if someone just walks into the clinical or like takes this survey, they may like fake it and pretend that they don't have depression at all. But then if they like, for some reason wants, I guess, more advantages, for example, taking SAT test, maybe like if you have depression or any of those mental illnesses, you may get more time taking it. So they fake the depression test just to get more time and more advantages. And later on, you also see that we developed an image-based survey that is less biased. And we also examined their Twitter tweets, which is a truthful reflection of their daily lives. And the second issue is that it's more expensive and less accessible. And the third one is that there's delay between data collection and diagnosis. So between that time where they're just like calculating the data collection and diagnosis, they're like maybe the times where the patients, they like fall more depressed to the point where like the survey they just took may not help at all. And yeah, that's basically how the PHQ-9 goes.
Okay, besides the current psychiatric approach, we also review the existing AI approaches for depression detection. Since 2000, machine learning algorithms have been popular for natural language processing sentiment analysis. More recently, deep learning has been applied for text classification. AI depression detection research results have been reported using Twitter, Facebook, and other social media posts. The table on the side and the next summarize the research advancements in the reverse chronological order. For example, the most recent paper is mining Twitter data for depression detection. The aim is to offer a platform to interact with patients for depression detection. It used lexicon-based and classification-based approaches. It retrieved 3,754 tweets with depression and related keywords and yielded an accuracy of 78% to 79.7%. Another example is the multimodal named entity recognition for short social media posts. The purpose of this research is to incorporate relevant images in social media posts to augment textual information to outperform the existing image-only or text-only models. It used a hybrid neural network combining both text and images. It retrieved tweets from around 3,000 Twitter accounts and yielded an accuracy of 86.6%. After reviewing around 25 research papers, we noted the general pattern in existing AI approaches. Datasets use Twitter data and data gathered from real people, and models convolutional neural network, gated recurrent unit, support vector machine, and naive Bayes. The third point is research focuses with detecting depression using social media data like Twitter. Also, we identified the limitations in the existing AI approach. Lexicon is not depression symptoms based, so words can be ambiguous. Also, the result is subjective to lexicon DB quality. No leverage of well-established psychiatric clinical depression detection practices defined by American Psychiatric Association. Does not examine symptoms in prolonged period of time, which is 2 weeks. High precision at the expense of low recall and lack of context sensitivity. For example, let's review the two messages, cut my finger opening a can of fruit versus scars don't heal when you keep cutting. The existing AI approaches either analyze the sentiment of the whole message or only analyze individual words. In fact, to achieve higher accuracy, we need to analyze both the sentence level as well as the individual word level. There is no sentiment analysis to determine positive, neutral, negative polarity for the whole context. Cut is not a depression indicative word in the first message, but is an indicative word in the second message, because the first message as a whole reflects a neutral sentiment, while the second indicates a negative sentiment. The proposal in our study leveraged the best practices from both psychiatric as well as AI fields. A multimodal AI framework was used on multi-channel data that was semantically correlated. Videos and images, nonverbal cues, and natural language verbal cues. They complemented each other to reveal patterns that were not visible when working with individual channels alone. This proposed approach consolidated data from various sources to produce more accurate depression detection. In this diagram, the blue boxes represent AI components, the green boxes represent best practices from the psychiatric field, and the stars represent the unique design for adolescents and young adults. The A through E box means A is data collection, B is 9 symptoms detection with natural language processing on Twitter accounts, C is depression detection with sentiment analysis on contextual survey results, D is facial emotion recognition with CNN on multimedia survey results, and E, multimodal aggregator for the final prediction result. We will explain them in detail in the following slides. Module A, data collection. Our data is from two sources. The first source, tweets per user account. The tweets are labeled with depression or non-depression based on the user's self-declaration in their profile, name and bio. The second method, the survey results based on our depression survey uniquely designed for young adults. Research shows that youth who reported higher depression symptoms were 2 times more likely to disclose negative emotions online and were 3 times more likely to disclose various hassles online than their peers who reported lower symptoms. Therefore, part of the study focused on Twitter data. The other part focused on a uniquely designed depression survey. Twitter data per user account was retrieved using Twitter search engine streaming API. The data was labeled into depression and non-depression data sets based on the Twitter account's self-declared user profile, for example, name and bio. Data cleansing and normalization was done before training. For example, remove stop words, punctuations, and emojis, and conduct case normalization. The next slide shows the young adult age relevant survey. It gathered both contextual as well as video multi-channeled content for AI analysis. The proposed solution transformed the traditional clinic questionnaire into a new survey design that enabled AI multimedia data analysis. Since the audience were adolescents, the young adults who would take the survey outside of a clinical setting, the survey was made to be more age relevant and engaging. Included mood induction images intended to cause an emotional reaction. The image list used in the survey has been revised based on feedback from 51 US high school students. Those surveyed were instructed to improvise a short video reflecting their emotional reaction to the chosen pictures. The response was converted to text for natural language processing. The facial video was converted to frames of images for facial emotion recognition. Besides video data collection, the survey inherited some essential questions from the clinic questionnaire PHQ-9. The scoring algorithms used in PHQ-9 were applied here. This survey was sent to 300 plus US high school and college students covering both depressed and non-depressed users. A total of 223 participated. After filtering out the partial results, 89 were used as quality survey results. Among the quality ones, 18 were labeled with depression and 71 with non-depression based on users' self-declaration.
So now we're moving on to Module B, which is 9 symptoms detection with natural language processing on Twitter accounts. Two things we want to highlight in our proposal is number one, to comply with psychiatric questionnaire-based diagnosis based on symptoms in the past 2 weeks, the Twitter data were grouped into 2-week batches. This depression analysis was based on a period of time instead of a snapshot of time to better reflect the status of a user. And number two, the general polarity-based lexicon only maps each word to positive, negative, or neutral. The sentiment analysis result is very coarse-grained. We use more advanced symptom-based lexicon for sentiment analysis. Each word is mapped to one of the 9 depression symptoms. Therefore, our result showed detected symptoms. This approach is able to avoid ambiguity of the words and increase accuracy. For each batch of the 2-week Twitter data for the given account, the system checked the symptom indicative words. For example, for the word loss of interest, the system checked occurrences of words absence of pleasure, moody, bored, no job, and etc. to determine whether the user has loss of interest symptom. Furthermore, our symptom-based lexicon is uniquely defined for adolescents and young adults, meaning the lexicon includes the words that young adults are likely to communicate. And adolescents and young adults suffering from depression are not likely to directly describe their feelings. They tend to use their own vocabularies that are often overlooked in the general lexicons, like ulcers, bullying, down, irritable, arguments, instead of the words depressed. In order not to miss the clues, our research defined young adults' depression indicative lexicon after studying the following 3 areas. First one is adolescents and young adults' online social media posts and the self-declared depression Twitter accounts. Second one is the multimedia survey results analysis from 89 American high school students. And the third one is existing research on depressed young people's vocabulary choices to assist age cohort analysis. This study used the age predictor library. And after verifying against the label test data, the labels which is extracted from the Twitter account self-declared user profile, the precision yielded at 77.77%, recall at 98.34%, and accuracy at 86.3% for all Twitter account depression detection, and the label -1 for depression. And now let me just draw the confusion matrix, which is basically a performance measurement for machine learning classification problem, where the output are in 2 classes for simplicity, which is the first one is negative and second is positive. So I'm just going to annotate right now. And so let me just create a board so I can draw on here right now. And then I'm going to draw the axis in black right now. Okay, and so here's the label. Label is basically Y. And then the prediction is going to be X, which can be also called Y hat. And then I'm just going to make a text in black. And so first one is going to be negative. Okay, so the top is negative. The bottom here is going to be positive. And down here, it's going to be negative. And then right here, I'm going to make it positive. And so using another box to draw it, true negative is going to be here. False negative is going to be here. False positive is the next box here. And then true positive is right here. So just for your convenience, I'm just going to label them. So here is true negative. I'm going to label it as TN. False negative, which is going to be FN. And then false positive, which is going to be FP. And then true positive, which is TP. And then from here, using precision, as you can see right here, is 77.77%. But like just for simplicity again, we used only 2 classes, which is negative and positive, whereas our actual precision had 3 classes, which is negative, neutral, and positive. But with just 2 classes, the precision is going to be true positive over true positive plus false positive. So just drawing that out, it's going to be, I'm just going to draw in green. So the total or the denominator is true positive plus false positive. So it's right here. And then we're going to have the numerator as true positive. So that's right here. And basically, precision is which one you actually predicted correctly out of the ones that you thought were correct. And then there's recall, which is basically true positive over true positive plus false negative. And I'm going to be annotating in blue. So here's going to be your denominator. And then your numerator is going to be true positive right here. So I guess this one is just out of the ones that are actually positive, which ones did you get that are actually positive that you guessed correctly, I guess. And then for accuracy next is basically the true positive plus true negative out of the whole data set. So using purple, I guess the whole data set, which is the denominator, is going to be the entire area here. And then the accuracy is just true positive plus true negative over the entire data set. So here is true negative, and then here is true positive. So that's going to be your accuracy. And now I'm just going to clear my annotations. And the right-hand side you see here shows the sample Twitter account analysis results. And this account shows sadness symptom and suicidal ideation symptom. And the Twitter account name, which is like AI and all the way to like N, is obfuscated for privacy consideration. And move on to the next slide. The diagram on the left right here shows the confusion matrix for experiments on a 10K data set. So you see here, there's 3 classes, which is negative, neutral, and positive. And then the diagram on the right here shows the depression word cloud in order to visualize the keywords in the collected tweets. The word cloud may show partial words because this study basically hid some inappropriate words for the audience. And yeah, that's basically our word cloud and confusion matrix for this slide.
Now it's time to move on to our module C, depression detection with sentiment analysis on contextual survey results. The contextual content includes the video to text converted content. It was sent to the AI component C for sentiment polarity analysis. First, each survey result went through the sentiment polarity check using Vader library. Vader is a rule-based sentiment analysis library. Comparing with TextBlob, Vader works slightly better with user-generated short content. The sentiment score was assigned to each survey result. Then TF-IDF was used for text vectorization and feature extraction. Term frequency inverse document frequency TF-IDF measures how relevant a word is to a document in respective to a collection of documents, also known as a corpus. The more frequently a word occurs in a document and the less documents in the corpus contain this word, the more relevant this word to this document. For example, if a document has high occurrence of the word medicine, and this word is not very popular in the whole corpus, this means that medicine is one of the keywords that represent the meaning of this document. However, the words such as this and occur very frequently in a document. They also occur in many other documents in the corpus, so they are not good representations of the meaning of the document and hence are ranked low. In this AA component, Vader sentiment scores and TF-IDF extracted features were sent to the logistic regression model for classification. The accuracy peaked at 87.76%. The average accuracy for TF-IDF was 88.96%. Considering that TF-IDF yielded a more consistent trend, TF-IDF was adopted in the final AI framework in this study.
Now moving on to the next slide. The next module is D, which is facial emotion recognition with CNN on multimedia survey results. Our study took a multimodal approach to analyze both nonverbal and verbal cues for increased accuracy. Facial expressions are part of the essential nonverbal cues from our survey results. So the survey results contains the video responses from the surveyees after they looked at the mood induction images. Module D analyzed the image frames in the video into one of the 7 emotions: anger, fear, disgust, happiness, sadness, surprise, and neutral. Can you guess what the emotions on these slides are? So from left to right, there are happiness, sadness, anger, and surprise. And just for fun, pretend you're still a child who just came back from school after taking a test. So on the very left-hand side, this may be what you look like after your parents ask you about your test, and you may be like, oh yeah, I did great. In fact, I got above 100%, when in fact you failed. And then obviously your parents will also be happy once they see your report card on the second emotion. That may be your face when they start scolding you about it. And then the third emotion, which is anger, are basically what their faces might look like. And then if you have siblings, then theirs might be similar to this face on the very right-hand side. And that may be like when they realize that they scored a lot higher than the 2%, which is basically the score that you actually got. And this slide shows a traditionally fully connected neural network, which is usually called ANN, and assume the input image has 1,000 by 1,000 pixel dimension and 3 color channels. And the first hidden layer has 100 neurons. In this case, the fully connected neural network needs to generate 1,000 by 1,000 by 3 by 100 number of connections. Each connection requires 1 weight parameter and 1 bias parameter for a machine to learn. Therefore, there will be 600 parameters for the machine to learn. So basically how this works out is that you have 1,000 by 1,000 and you multiply that together, so that'll be 1,000,000. And there's 3 color channels, so you multiply that and that becomes 3 million times 100, which is going to be 300 million. And that will be like 300 million connections, as you see here. But on each connection, there's 2 parameters. And the first one is weight, the second is bias. So you multiply 300 million by 2, which becomes 600 million. And that's basically how you get 600 million parameters. And you can imagine that the learning time will be extremely slow. So fully connected neural network is not a feasible solution for image processing. And in fact, convolutional neural network, also known as CNN, is a better fit for recognizing and accurately categorizing image and video input. We chose to use CNN to achieve facial emotion recognition. And through each hidden layer, the machine can recognize facial features from the most granular level to the most complex elements. This intuition shows that the machine first recognizes the vertical edges, horizontal edges, diagonal edges, and etc. The next hidden layer recognizes the eyebrow, nose, and mouth. And then the third layer recognizes the faces. This is why the deep neural network can analyze more complex patterns, but the shallow neural network or some traditional machine learning algorithms cannot. And you may ask what's the fundamental difference between the convolutional neural network and the fully connected neural network that enables the effective image processing. And the key difference to that relies on the filter. In convolution layer, the computer extracts high-level features by moving a kernel, also known as the filter, over the entire image and reducing its dimensions. So on this page, it shows how the vertical edge filter works. So the left-hand side you see right here of the 6x6 box illustrates the pixels on an image. And then the 3x3 box, which is the filter, that's like basically the filter. And then the next one is the 4x4 box, which illustrates the filter results. And the filter is applied to the image area like a rolling window. So first we apply the filter to the top left corner of the image. And the pixel number is multiplied with the corresponding number in the filter. And all the multiplication results are summed up. So basically, I'm just going to annotate on how this works again. So using red, like this box is highlighted right here, the filter is applied here. And then with this, all the 10s here is going to be multiplied corresponding to this 1. So 10 times 1 is 1. 10 times 1 is 10, obviously. And then with 10, you multiply, or you add up the 10s right here. So that's going to become 30, since 10 plus 10 plus 10 is 30. And then right here, 10 times 0 is 0. And then with that, you can have 0, 0, and 0 right here. And then 0 added up together is just 0. So that's going to be 0. And then this 10 right here, 10 times -1 is -10. And then the other two 10s are going to be multiplied with -1 also. So that's going to be -10, -10, and -10. And with that, added that all together, it's going to be -30. And then 30, you add these like 3 numbers up, and 30 plus 0 plus -30 is just going to be 0. So as you can see here, all this 9 spaces is going to be into 1. So this is just 0 right here. And now I'm just going to clear my annotations. And the filter is like then applied to the next rolling window area, which is highlighted in green right here. And after finishing the first row, the filter move on to the second row. So after this green area, it goes right here, and then it goes here. And since it can't go like to the right anymore, it goes on to the second row, which just starts off with this row right here. And then once the filter is applied to the whole image area, the vertical edge will be surfaced on the right-hand side of the 4x4 filter results. So you see, I'm just going to annotate again, but instead like I'm going to highlight it in purple. So with this, that's the middle of the input image, also known as the edge dividing the shades. If you look at the filter now, the edge becomes this spot, which is basically the 30s, the places that had 30s in it. And although it's thicker, it's not ideal, but like, it's not ideal because it's not as clear and sharp as this line over here. But like the vertical edge filter works, as you can see. And then each number in the filter is called one parameter. So this 3x3 filter contains 9 parameters, and the machine can like self-learn and tune these parameters to find the best values to use. And I'm just going to clear my drawings again. And the beauty of this filter mechanism is that no matter how big the large dimension is, the number of parameters in the filter has no change. So the machine does not need to learn more parameters, even if the image size is increased dramatically. This, in fact, demonstrates one of the key properties of convolutional neural network. And due to this property, CNN image processing requires shorter training time and less prone to overfitting because there are less parameters to learn. For example, if you have 10 filters that are in 3x3x3 dimension for one neural layer, this layer will have 3x3x3 plus 1 bias times 10, which is going to be 280 parameters. And the bias is just added by 1 because like the bias allows the graph to like kind of move around. So for example, I'm going to annotate again, and I'm just going to draw the axis in black, or I guess purple in this case. So if you have like this graph right here, and then your points are like over here, for example, or no, not points actually, it's a line. So if your line is like here, then with the bias, you can move around and find y-intercept. Without the bias, you can only go through the origin. So there's a lot of restrictions if you don't add the bias. And so for a color image, it has a third dimension representing the red, green, blue color channels. So the filter needs to be 3-dimensional as well. And in order to reduce the feature dimension sizes, reduce computational power, and prevent model overfitting, max pooling is applied. So max pooling layer extracts the dominant convolved features in the example on the page, like the biggest number, it's going to be extracted. So 1329, 9 is the biggest number, so it's going to be extracted right here. And then for the light blue one, 2, 1, 1, and 1, 2 is the largest, so it's going to be here. And then for the question marks, for the green question mark, or like the black question mark on green, 6 is the greatest number here. So 6 is going to be replaced with the question mark. And then for the red one, 3 is the greatest, so 3 is going to go in the red box. And then moving on to the next slide again. The labeled dataset used for facial emotion recognition training contains 35,000 labeled images of people with different facial emotions, which are anger, fear, disgust, happiness, sadness, surprise, and neutral. So we located the dataset from Kaggle, which is a great website for data science. So in the data processing phase, the features value were normalized to a common scale between -1 and 1 to facilitate efficient gradient process and avoid oscillation, which is like a zigzag right here, which is not shown, but like it's with the unnormalized, it's going to go with the zigzag, and that's not as efficient as normalized, which just goes straight down in the line. And let's just like take example of 2 input features, age and income. So age ranges are from 0 to 120, and income ranges are from 0 to 1 million. So age range, you can't like go from 0 to 1 million because nobody really lives that long. But income ranges, it can go like really high to 1 million. And the age range, of course, is much smaller than the income data range. And the income will influence the result more due to its larger value, but this doesn't necessarily mean that it's more important as the predictor. And first we subtract the mean, and then we divide the data by standard deviation, which is basically the normalized variance. And as you can see, the data is now centralized in the origin and has the same range between -1 and 1. So from here, this is the original one, and then it moves down to here so that like this origin becomes up here in the center. But then since this is not a square yet, it kind of just squishes the sides and it becomes a square right here. And then activation function is applied for data transformation between the data, before the data is output from a neural network layer. So on this slide, I'll just introduce 2 activation functions used in our deep neural network. First one is rectify linear activation function, also known as ReLU, and the output will be like, this like function will output the input directly if it is positive. Otherwise, it will output 0. And then it's usually the default activation function for many neural networks because a model that uses it is easier to train and often achieves better performance. The second one is softmax. There's an X at the end, so it's softmax. And it's used for a multi-class classification. And this function takes an input of a vector containing k real numbers and normalizes it into k probabilities. Each probability will be in the interval of 0 and 1, and the sum will be in 1. In the facial emotion recognition case, given a facial expression image, the softmax function will output the probability of the expression to be angry, happy, sad, and etc., which is basically the 7 emotions. And the probability of each emotion will add up to 1. And then in the CNN architecture, 3 hidden layers were built with filter size of 3 by 3 and activation function of rectified linear unit, which is ReLU. Additionally, dropout function was added to avoid overfitting. And towards the end of the architecture, neurons were linearized with flatten function to enter the fully connected dense layer. And for the output layer, the softmax activation function was used to output for the multi-class classification results, which is categorizing the images into 7 emotion groups. And during the prediction phase, Harkisgate was used to recognize facial areas to drive higher accuracy. And the videos from the survey result were processed to frames of images using CV2 library. And after tuning the hyperparameters and adjusting the epochs, which is basically the amount of steps, the model peaked at 83% accuracy when epochs reached 80.
Finally, we come to the last module, Module E, Multimodal Aggregator for the final depression prediction results. Towards the end of AI prediction, the system aggregated the AI scores from both facial nonverbal cue analysis and natural language-based depression symptoms analysis to determine the final prediction result for the given user. 5 experiments, each conducted on 10,000 data entries, reached consistent results with an average accuracy of 88.31%, higher than the existing natural language analysis models.
Yep. And then now it's going to be a video time, which is basically Raymond sharing his part. So I'm just going to share the YouTube link. Okay. Actually, yeah, here. So tell me if you can hear the sound. And yep, that's basically the video of Raymond sharing his part. And now I'm going to just transition back to the slides. Okay. So here's a list of our references that we just use for our learning journey.
Now we are going to transition to our second topic, visual approach to introduce algorithmic thinking. Raymond, Claire, and I co-authored the book Algorithm Thinking for Adventurous Minds, Quest for Fundamental Algorithms with Visualization and Python Code. This book is about how to work smart to avoid unnecessary work. Algorithm thinking is about identifying the most efficient steps to solve a seemingly complex problem without detouring. It is a necessary skill for both our work and life. Since it was published on Amazon, we received some really encouraging feedback from the paid customers, which we highly appreciate. For example, you can see that some people have written fantastic insights and very well done. Kudos to the authors with the cute backstory and lovely illustrations. This book makes some basic algorithmic concepts a lot more approachable for younger students to learn. I think some of the authors are still in high school, which is really impressive. It's an amazing feat to produce a high quality book.
Yeah. And the book Algorithmic Thinking for Adventurous Minds was ranked #1 in programming algorithms and Amazon's hot new releases in April 2021. And this book documented our learning journey. It introduces many computer science terms like Fibonacci, graph, recursion, queue, stack, greedy, dynamic programming, Prim, Kruskal, Dijkstra, BFS, which is breadth first search, DFS, which is depth first search, and etc. And I'll just go on the next slide. While these concepts have rigid definitions and are not as easy to grasp as of first glance, we try to describe them in visualizations, graphs, miniature poems, and fun facts. Our intent is to offer a unique approach to engaging with both visual learners and reading or writing learners. And here is basically a poem that we made, and then a flow chart. And then here's a Fibonacci use case with the golden ratio and golden spiral. Here's a part of a code. And then here is the table we use for dynamic programming. And in the book, we introduced a magic tool called Kali Lens. It symbolizes a set of problem-solving methods that are used to abstract the problems and identify algorithmic solutions in a computer-friendly way. When we use the lens, we'll see a crystal clear world out of the chaotic reality.
The computer world is an animal kingdom. Many programs were named with animal names. For instance, we name our main 4 characters, the best 4, as Dark Knight, an adventurer born to lead, Banana Split, intelligent and enthusiastic, Bubblegum, creative and cheerful, Mighty Python, an embodiment of computer science. When it comes to algorithms and code, he's the one to call. By the way, you have to love animals to continue reading the book? No, but if you start now, together we can make the world a better place. Our story takes place in a land of apple pie. The apple is a symbol of realization, healthiness, and innovation. Newton's apple, an apple a day keeps the doctor away, or an Apple laptop, and pi is for math. The audience will go through 5 days of adventures with us to explore a series of challenges and naturally come up with the solution steps. Without forcefully knowing it, you will master the skill of algorithmic thinking. On day 1, greedy algorithm to solve a fractional knapsack problem, help Banana Split eat a variety of nuts. On day 2, dynamic programming to solve 0 through 1 knapsack problem and coin change problem, help to help Bubblegum get the most drinks. On day 3, Prim's and Kruskal's algorithms to solve shortest path problem, flow the righteous invention from the gate of summit to all the cities. And day 4, Dijkstra's algorithm to solve single source shortest path problem, seal the gate of traceback to stop the toxic inventions. On day 5, breadth first search and depth first search to solve maze problem, the best 4 back to the future through maze. And now let the adventures begin.
And we'll give an example here. So in day 3 of the adventure.
We can move on to the next slide.
Oh, okay, sorry. Wait, yeah. Is there a lag for you? Okay, so we'll just give an example here. In day 3 of the adventure, the best 4 mission is to build pipelines so that they can send righteous inventions to every city. And building the shortest pipeline across a given set of location is the shortest path problem in graph theory. So the book first introduces the concept of a graph. The map has overwhelming details, land, ocean, castle, and etc. And after we filter out the details and only keep the essential information relevant to our mission, we got a graph. The graph is an abstraction of a real-life map. In graph, cities are the nodes or called vertices, and the roads are the connection or the edges. Besides, we are also concerned with distances, which are the weights of the connection. In a graph, there can be cycles. For example, there's 1, 2, 3, 4, 1. And then if there's a cycle, it means that there is more than one path connecting to a pair of nodes. For example, between nodes 2 and 4, you can go via 2, 1, 4 or 2, 3, 4. And for a pipeline mission, we need to identify the shortest path connecting all the cities by keeping only one path between a pair of nodes and a minimally connected graph. To achieve this, we need to avoid cycles. And a tree is a type of graph that does not have a cycle, and hence there's only one path between a pair of nodes. And usually in computer science, we draw an upside down tree and put the root node on top. As you can see here, 5 in this case is the root node. And a spanning tree is a type of tree that spans across all the nodes in the graph. And the cost of the spanning tree is the sum weights of all the connection in the spanning tree. For example, the cost of tree 1 is basically just 1 plus 7 plus, or 5 plus 7 plus 1 plus 6, and that's going to become 19. The cost of tree 2 is 17, cost of tree 3 is 21, and cost of tree 4 is 15. And the fourth one on the slide has the minimum cost and hence called the minimum spanning tree, also known as MST. And the minimum spanning tree, MST, is exactly what we want in order to build the shortest pipeline. And this graph shows the relationship of graph, tree, spanning tree, and minimum spanning tree. And so connecting this with the real world, between the mid-19th century to early 20th century, the advancements in technologies during the Second Industrial Revolution enabled the widespread adoption of railroad, gas, water supply networks, and electrical power systems. Finding the most cost-efficient coverage of the locations became a more and more common problem. In 1926, Barufka was asked by his friends from the Electric Power Company to design an electric power network. Barufka modeled the network as a minimum spanning tree. Now I'll just briefly introduce two of the most famous algorithms to find the minimum spanning tree. First one is Prim's and the second is Kruskal algorithms. And first, let's just take a look at Prim's algorithm. So it starts with a node that connects to the shortest connection. In this case, on the top, between nodes 1 and 4. And for each step, the algorithm selects the nearest node that is not yet in solution. In this case, it is node 2. So it's 2, 1, 4 in this order. And then after that, it's gonna be connecting more of the shortest path. So it's gonna be here, it's gonna connect 3. So there's gonna be 3, 2, 1, 4. And then from here, moving on, we have to connect with 5. Since if we connect 3 and 4, it's going to become a cycle, and plus 4 and 5, which is the weight is 6, is less than 7. And right here, now it is forming a minimum spanning tree. And then Kruskal's algorithm, the connections are the first sorted from shortest to longest, as you can see right here. And then the algorithm includes the connection by order. If there's no cycles form, if there's no cycles form, and if a cycle is formed by including a connection, this connection will be ignored. So in this case, the algorithm first chooses connection between nodes 1 and 4, the connection between node 1 and 2, then 5 and 6, then 5 and 7, finally includes connection between 2 and 3. The connection between 3 and 4 cannot be included to avoid the cycle. So yeah, here's basically the visual of how it works. So flowchart and code implementation are also included in this book. So the flowchart here and this code right here is both for Kruskals. And as you can see, it's basically, there's a lot of comments in this Python code. So hashtags are basic comments. So in case you don't understand the code, you can always read the hashtag, which is basically what it means for like the next line. And finally, I'll show a video demonstration of the day 5 adventure, which is solving the maze with breadth first search algorithm. And so I'm just going to go on YouTube and basically show you the video. And so here, as you can see on the bottom, there's something called like the brick and then this like grass, like, or this plant right here. And then these two are basically barriers for the maze. And right now, I guess the bricks can be used for the perimeter of the base just for fun. And then there can be like, you can place down the bricks in different patterns you want, in any pattern you want. And then this creates like a maze. And then moving on, like you can even use the grass right here, or the plant, I guess. So here you can like select the plant and then click on the plant or in whatever place you want to put it in. And once you click demo mode and then you click solve, it's going to show you how it goes. And Q is basically the base for breadth first search, which is BFS. And then the gray ones are the ones that are already explored. And then the blue ones are the ones that haven't been explored yet. And then the black is the ones that is being explored. So basically the gray is the past, the black is the current, and then the light blue is the future, kind of. And then it goes slowly for visualization or to demonstrate how breadth first search works. And after a while, it goes through explores like the entire path. And then towards the end, which is about here, once it reaches the exit, then it immediately shows you a path, which is like highlighted in grass, kind of show you how the maze works in like the shortest path. And for right now, if you put it in like play mode, then it's not going to take this long to find the path. In fact, it's going to take a few milliseconds before it shows you the path. So it's really quick. And now I'm just going to be moving on back to the slides.
So that's actually the end of our presentation. Thank you everyone for attending today's seminar, and thank you hosts from the Association for Computing Machinery.
Okay, thank you very much, both of you, Claire and William. That was a very wonderful presentation. Any questions from the audience? By the way, let's give a clap of applause. And probably what we should do is do a clap emoji on your chat box. Then, in the meantime, you can think about any questions you have. You can put it on the chat box, either Zoom or YouTube. I'll just monitor that. Any questions?
Okay. I'm seeing there are a few more questions here. If you guys have the chance to answer. The more interesting is, are your parents engineers?
Yeah.
Yeah.
My mom is a software engineer and my dad is a hardware engineer. So they're both engineers.
So
how do you decide which algorithms to explore?
Another question from Carl Anderson. How did you decide which algorithm to explore? Please explain.
So we went on Google and find like Quora or like Stack Overflow, for example. They're pretty good website and there's like a community kind of. And And then from there, you can kind of ask questions and then they answer it for you. Or like you can just like go on Google and search up some algorithms to use for a certain case. And from there, it kind of lists a ton of algorithms to use. And then we kind of go through them one by one to find what is like the most common algorithm to use and which one's the best to use. And also we kind of take computer science courses. So our teacher does tell us what to do, or like which algorithms are good to use.
Just like a traveling salesman problem. Choose the closest algorithm you come across.
Yeah.
Okay, Dave, I have another interesting question. Which Coursera courses did you take, and what year in high school were you in when you took them? I think this question must be for William.
Yeah, so there
Blair
are
is
like
not
two,
in high school yet.
yeah. So there's like 2 Coursera courses, I think that was like that I took. One I spent a little more time on. It was deep neural network and machine learning. It was taught by Andrew Ng. I don't know how to say his last name, NG, but it was like a 11-week program, and throughout the program, he would give a lecture in the beginning, and there would be fun exercises and like a challenging program at the end. And I think I've tried to go through the course a little faster throughout summer since I had a little more time, and that was during my senior year, between my senior year and freshman year of college. So I did that course then. Yeah.
Okay, here's another question from Carl again. How much drift in language using slang would be a factor, and how could you correct for it?
So there's some Python libraries, like I answered, that correct spelling and etc. But like we didn't actually process slang and tweets yet, and that may be our next step.
Okay, well, that's a future project, huh? Okay, well, I just need to read that out because we have more people like to hear your answer, not just on the text. Oh, I think this is William answered the question to Dave. Maybe William can repeat your answer to the bigger audience. The question is, do you think a change in the rate of smiling in social media pictures would predict depression, or are social media pictures too fake for that?
I think I wrote a response in the chat to everyone, and
could you read it yourself?
Yeah.
The answer aloud a little bit?
Yeah. So our facial emotion recognition is based on the survey result. And we designed the survey specific for the young adults and capture their facial emotion after viewing the emotion inductive images. Less probability that they fake their true emotions. So I agree with you that if we simply analyze the images on Twitter, the result might be a bit biased because those images can be skewed towards the emotion that the account owner would like to convey instead of their real emotion. And that basically we also analyze Twitter data in a prolonged period of time, hoping to reduce the risk of 1 or 2 pictures dictating the depression result.
Okay. I hope you can raise your voice a little bit too.
Oh, sorry, did I speak too quietly?
All right. Okay, let's see what else is interesting. I think I covered everything here. I don't see any more questions. Does anybody else on the floor still have a question? I think we can close. Can we? SR?
Yeah, I think so. That I don't see any more questions, neither in YouTube nor in Zoom. So
Okay.
I think we should
Well, thank you very much.
Thank you very much, both of you. You've done a wonderful job for, especially for the grade levels you are in. It's a kind of a very tedious and very rigorous job, and amazing, amazing results you got at the right time. Thank you very much. Wish you both very good luck in your future studies, and hope we meet you somewhere, and then you come back to ACM to present more things.
Oh, I do see a more question here. What Coursera courses did Claire take, and what grade was she in when she took them?
Oh, I didn't take any Coursera courses, but I did get some like info from William as he took the courses he just said. And then he kind of like told me some information about it. And that's basically how we communicated with each other.
Okay. Well, that's neat. So William learned first and then just turn around to tutor you, huh?
Yeah.
You're saving a lot of time that way. Okay, let's see. All right. Okay. Well, thank you very much. Okay. Yeah. Thank you.
Thank you very
All right,
much.
thank you for
too.
hosting.
Call it a day.
Yeah.
Good luck, both of you.
Thank you.
Thank you.
Okay. Well, hopefully you're joining our data science summer camp soon, huh?
Yeah.
As teachers.
All right. Thank you.
Thank you too.
Good job.